Chapter 6, sections 1 and 2. Now, I put this together because a lot of the information that is in section 1 is exactly the same that's in information in section 2. Section 2 is a step up. And what I've learned about you guys is you hate having more and more and more and more assignments, correct? You'd rather have one concept explained to you one time and practice over that than having 5 worksheets. Agree?
Yeah.
So that's what I've done. I've taken 2 sections and I've combined them into one because it is essentially the same material. Do we all understand that? So here we go. Simplifying radical expressions. Examples. Number 1, off of tonight's homework. I have negative times the square root of 25. What does the negative mean to you? What does that negative mean? What is it? Negative 1. Okay? So what I have here is negative 1 times the square root of 25. Okay? Now, does everybody understand that what's inside this check mark is a 2? That 2, as you watch up here, is going to physically disappear. And the reason why it's going to disappear is because it is not supposed to be written there. It's the phantom 2. You know how we have the phantom 1 whenever we have 1x? We don't need to say 1x, we just say x. Okay? Well, whenever I say the square root, the 2 is understood to be there. Now, what I'm asking for is what number multiplied by itself gives me 25? 5. So what you're telling me is that 5 squared is 25. Yes or no? Okay? Now, do you remember, whenever we were solving equations, we had x squared, and I said, how do we get rid of that x squared? What did you all do to it? You took the square root of both sides, didn't you? Right? So that meant that the power of 2 and the root of 2 canceled each other out. Do we all agree with that? To give you negative 1 times 5, which is negative 5. Now, clearly, I showed you a lot of work there. I'd like to think that you guys would say the square root of 25 is 5, times the negative is negative 5. I walked you through every thought that should go through your head as you're doing that problem. I kind of would like to see you go from there down to there without any problems. Do we understand that? Okay, number 4. No one memorizes things in decimals unless you're a precision machinist. I have not ran into a lot of kids who know their decimals unless you've been a precision machinist program. Okay? So with that said, what is 0.001?
1,000.
The 1 is in the thousands place, so I'm going to make this into a fraction. I'm going to make that the cube root of 1 over 1,000. And with a fraction, we have the numerator, which is the top, and the denominator, which is the bottom. And what we're going to do is we're going to divorce these. We're going to make this the cube root of 1 over the cube root of 1,000. Do we see that? Now, what number multiplied by itself 3 times is 1? 1. What number multiplied by itself 3 times is going to be 1,000. So what this means is I'm going to have 1 cubed is 1, and 10 cubed is 1,000. Do you need to write this stuff? No. What am I doing again? I'm showing you all the thoughts that go through my head as we complete this problem. The root of 3 and the power of 3 cancel out to give me a 1. The root of 3 and the power of 3 cancel out to give me the 10, to give me 1/10. Do we see that? When the roots and the power are exactly the same, they can cancel things out and it'll give you the answer. Does that make sense, folks? Okay, you'll need to write this down on a sheet of paper. Now, it says when you are taking the even root is important here, of a variable. A variable is also important. And the outcome has an odd power. Outcome, what's outcome? What does that mean? The result of a calculation, right? The result of a calculation would be the outcome. When the outcome has an odd power, that means you have to use absolute value bars. I'll give you guys a moment to copy that down before I explain further. Okay, what does this mean? Well, tell me this. An even root. What's an even root? Give me an example of an even number. 2, 4, 6, 8. Those are all even roots, yes? Okay? So when I have an even root, meaning the square root or the fourth root, then I need to think about what type of a number I'm going to be taking the even root of. For example, can I take the square root of 4? Yes, what is the square root of 4? 2. Well, how about, can I take the square root of -4? Well, what is the square root of -4? Plus or minus 2i. Did you see how we went from the real number system into the imaginary number system? Okay, well, what we're operating on today are all going to be real numbers, no imaginary numbers. So since I cannot take, a variable can either be positive or negative. Would we all agree with me on that? A variable is taking the place of a number, and we don't know if that number is positive or negative, correct? So what we have to do is we have to plan according to being positive case or being the negative case. Now, if I have an odd outcome for my exponent, I require absolute value bars. Why is that? Let's say, for example, I have an x cubed. If I take -2 and I cube that, what does that give me? -2 times -2 is +4 times -2 is -8. Can I take the square root of -8? No. So therefore, what I have to do is take the absolute value of -8. And what is the absolute value of -8? 8. Then I'm okay. So let me show you some examples of this. Number 5 off of tonight's homework. What I have going on there is the square root of 81 times x to the 4th. So what I'm going to do is I'm going to divorce these. This is 81 times the square root of x to the 4th. Okay? That number multiplied by itself 2 times gives me 81. 9. Now, watch very carefully. Do you see this? As soon as you see me put a line through this with an arrow, that means that that comes out as a 9. Do you remember seeing that from Algebra 1 teacher, maybe? That comes out as a 9. Now, the next thing we're going to do is we're going to talk about how I can rewrite this. Is my power, which is 4, divisible by my root, which is 2? Yes, so what we're going to do is we're going to write this as power over root. Power over root. So this is going to be x's raised to the power is 4, root is 2. Well, what is 4 divided by 2? 2. In other words, this is 9x squared. In other words, this comes out as an x squared. And the reason why it comes out as an x squared is because I took my power and I divided it by my root. Do we understand that? Okay? Now, here's the question. What type of a root am I talking about here? An even or an odd root? Which one is it? It's an even root. Why? Because it's squared. And then I need to look at my outcome of my lovely little exponent. And what is the outcome of my exponent there? Is it even or odd? It's even. Now tell me, if this is an even root, or an even power, I should say, if I take a negative number and I square it, what's the outcome going to be? So -2 times -2 gives me +4. Am I ever going to get a negative outcome? No. So since I'm never going to get a negative outcome, I do not need absolute value bars here. Because it doesn't matter what x is, when I square it, it will always become positive. Do we all understand that? So there's no absolute value bars needed there. Okay? Now let's go to number 6. If we look at number 6, what did I do with number 5 first? I split them up. I divorced them. So that's the square root of 121 times the square root of y to the 10. What number multiplied by itself is 121? That is 11. So this comes out as an 11. And then how did I rewrite this on problem number 5? What did I do? I did power over root. Y to the 10 divided by 2. And what is 10 divided by 2? 5. So this is 11y to the 5th. Now, I need to determine if I need to have absolute value bars. Well, what is my lovely little even or odd root here? Is it even or odd? It's even. So since it's even, I now have to come down here and I have to check my exponent and its result. What type of number is that, even or odd? That is going to be odd. Since that is odd, there's the possibility that that outcome could be negative. And am I allowed to take an even root of a negative number? No. So what do I have to do to make sure that this never turns out to be negative? I need to put the absolute value bars in there. So what I have is 11 times the absolute value of y to the fifth. Do we all understand that? That is ensuring that that y variable, whatever it is always going to remain positive, so I can take the even root of it. Does that make sense? Again, number 8. No variables in here, right? Since there's no variables, I don't have to worry about absolute value, do I? So let's go ahead and just calculate this. Well, I have negative 0.008. Does my brain think in decimals? No, so what should I do? I need to make this into a fraction. And the 8 is in the position of the thousandths place. And I'm going to put the negative with either the top or the bottom. It doesn't matter which one. Okay? Now, after I write it as a fraction, what do I want to do? Split them up and divorce it. So that's going to be the cube root of negative 8 over the cube root of 1,000. Now, what number multiplied by itself 3 times gives you negative 8? Careful. Negative 2. Do we understand that? Now, I'm going to rewrite this so that you can see this clearly. Parentheses negative 2 cubed over parentheses, what number multiplied by itself 3 times is 1,000? 10. What happens to the power of 3 and the root 3 in the numerator? What happens to the power of 3 and underneath the root of 3? Those cancel out and I'm left with negative 2. And what happens to the power and the root in the denominator? These cancel and I'm left with a 10. Now what happens to negative 2 over 10? And what does that simplify down to? Negative 1/5. Do we all understand number 8? Number 12. Do I have any variables in there? Yes. So now I need to concern myself with absolute value, correct? And now my question is when do I have the possibility to have absolute value bars? When do I have the possibility to have absolute value bars? When I have an even root with a resulting odd exponent, right? So this right here has an odd root. Am I going to have any absolute value bars here? No, because it's not an even root. This is an odd root. So since this is an odd root, no absolute value bars. Do we understand that? Since it's an odd root, I don't have to worry about even or odd because I can take the cube root of a positive number and I can take the cube root of a negative number. Do we understand that? Okay? So now, I'm going to go ahead and do what with this problem? I'm going to split this up. So this is going to give you the cube root of 64, x to the 9, over the cube root of 343. What number multiplied by itself 3 times is 64? 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 is 9 times 3 is 27. Need to go higher. 4 times 4 is 16, times 4 is 64. So is this a perfect cube? It is. So this comes out as a 4. Now what can I do with this x to the 9? Remember we do power over root. So what's my power here? That's going to be x to the power, which is 9, over the root, which is 3, all over. Now, can anybody tell me what number multiplied by itself gives me 343? Multiplied by itself 3 times. Well, I know I got to go much higher than 4, right? Yes? How about 7? 7 times 7 is 49. Well, what's 49 times 7? 9 times 7 is 63. 343. So the cube root of this is going to give me a 7. So now, am I done with that problem? Now, what is 9 over 3? 3. So this is going to give me 4x to the third over 7. Do I need absolute value bars? Why? Because it was an odd root. Since it was an odd root, I'm done. Yes? Again, number 13. Do I need to concern myself with absolute value bars? Why, yes, David? Because it is an even root. So what I need to do is I need to look at my root. It's a 4, so since this is an even root, I may have absolute value bars. I may. That's the key word. I may. I might or I might not. Okay? I need to calculate the problem, and at the end, what do I need to check? The exponent. So now, what about this m minus n? What can I do with that? This m minus n, what can I do with that? Can I separate them? I cannot separate them. It's the head and the body, so those go together. So what I'm going to do is I'm going to rewrite this as my power is 4 and my root is 4. So what's 4 divided by 4? Because I wrote the wrong thing. I said a 4 over there and I meant to write an n. Thank you very much. M minus n raised to the 4 over 4. What's 4 divided by 4? 1. So now I'm going to have m minus n raised to the first power. Does the 1 need to be there? No, but it's extremely helpful because I need to look at that. And I need to ask myself, do I need absolute value bars? Well, is that even or is that odd? It's odd. So do I need them if it's odd or do I not need them? You do need them, remember? So since this is odd, my answer is the absolute value of m minus n. And that's going to keep that to be a positive outcome every time. Do we understand that? Again, 15. Well, everything I've taught you so far is basically section 6.1. Now we're moving into 6.2, where we're basically taking two radicals, and instead of them being married, they are divorced. And now what are we going to do to make them simplify? Probably marry them, right? So these are two that are together here, and we're going to, they're separated, now we're going to write them together. And the reason why we're writing them together is, are there any? Is 45 a perfect cube? No, and the reason why I know this is because 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. 45 is in between 27 and 64, so I know it's not a perfect cube. Do we all understand that? Okay? And now what I can do is I can break this down. Can you tell me off the top of your head numbers that multiply to give you 45? 5 and 9. What is special about 9? 9 is a perfect square. So once we cannot break it down to be a perfect cube, we want to try to break it down into perfect squares. So that gives me 9 times 5. Well, how about 75? Can I break that down? 25 and 3. What's special about the number 25? It's a perfect square, which means now I'm going to ask this next question. How many 3's do I have inside there? Well, 9 has how many 3's in it? 2, and then I have another 3 over there. So how many 3's do I have? 3. How many 5's do I have inside there? I have 3 because 25 has 2 5's inside that. So that gives me a 5 cubed. Do you see that, yes or no? Now, I could divorce them, but instead of divorcing them, maybe what I need to do is simply do the calculation. What is the cube root of 3 cubed? That comes out as a 3. What is the cube root of 5 cubed? That comes out as a 5. Now, how are the 3 and the 5 attached on the outside? They were attached on the inside by multiplication. So on the outside, they're also going to be attached by multiplication. So what is 3 times 5? 15. Now, many of you may have taken 45 times 75 to get this big number, which was going to be 15 squared, and got the answer right away. Many of you are going to be too lazy to grab the calculator. You just won't do your homework, right? So instead of not doing your homework, let's just use logic and break it down. Do we understand that, yes or no? Again, 17. See how I'm trying to do at least 2 problems from every section on tonight's homework? See that? 17. The cube root of negative 16 times the cube root of 4. Do they have the same root? Yes. What do you think I could do? Marry them. So if I do that, I have the cube root of negative 16 times 4. Well, what is negative 16 times 4, folks? Negative 64. Is negative 64 a perfect cube? Yes. So what number multiplied by itself 3 times gives me negative 64? Negative 4 times negative 4 is positive 16 times negative 4 gives me negative 64. So this comes out to be negative 4 as my answer. Do we see that, yes or no? Notice how I'm showing you both methods here. So if you don't understand the one method, then your brain should grasp the other one. 20. Now what do you notice about this problem? It's been split up. Is that going to help me? Could I marry them and simplify it first? I absolutely could. So if I marry these, this is going to give me the square root of 54, x to the 5th, y cubed, all over 2x squared, y. Folks, what's 54 divided by 2? 27. Now, what do I do with exponents when the bases are attached by division? Subtract them. So what is 5 minus 2? So that gives me x cubed. What is 3 minus 1? Y squared. Do you remember that from back in the day? Okay, now here's my next question. What type of root do I have? Even or odd? I have an even root, don't I? Since I have an even root, I may have absolute value bars. Do we all understand that? I may have absolute value bars. Okay? Now, do I have any, is 27 a perfect square? No, but does it have perfect square factors? 9 times 3. So we're going to break this down. Now, what is my power on my x? It's a 3. What's my root? 2. Is 3 divisible by 2? Is there a number smaller than 3 that is divisible by 2? 2. So what we're going to do is we're going to break this down. We're going to make this x squared times x. Do I still have 3 x's inside there? Yes. Is that fair and legit? Am I able to do that? Yes. What is my exponent on my y? Squared. Is that divisible by my root of 2? Yes. So I leave that alone and make that y squared still. We all good? Okay. Now that everything is simplified, I need to go ahead and I need to take things out. So what is the square root of 9? 3. Can I do anything with the square root of 3? No. What is the square root of x squared? X. Can I do anything with x to the first? No. Since my power, which is 1, is smaller than my root 2, it stays inside. Go to the next one, y squared. That comes out as a y. Now, how is all the black attached up top? By multiplication. So what I have going on here is 3xy square root, and what's left on the inside? 3x. Now, that's all I can do to it, but I have got to ask the very important question up here. Do I need absolute value bars? Well, I need to now look at my exponents on each one of these. What's my exponent on the x? A 1. What's my exponent on the y? Is that even or odd? Odd. So could that possibly be negative? Yes. So I need to make sure that that's positive. So I'm going to have 3 absolute value of xy, square root of 3x. Do we get that, yes or no? Okay, again, 23. What do you notice about this problem? There's 2 numbers on the outside, and there's a jump on the inside of the radicals, and each of those terms are attached by what operation? Multiplication. So what we're going to do is we're going to marry these together, but we're going to make sure that we marry the jump on the outside and then the jump on the inside. Do we understand that? So if I marry the jump on the outside, that means I'm taking 7 and 2. What does that give me? 14. Very good. Now if I marry the jump on the inside, what's 3 times 6? 18. And how many y's do I have total now? 3. And how many x's do I have? 3. Okay, now I need to simplify like we did the last example. So is 18 a perfect square? No, it is not. So are there perfect square factors of 18? 9 times 2. So I drop down the 14 and I rewrite 18 to be 9 times 2. Now what about the y cubed? What did I do with that last example? I broke it down. Why did we do that? Because the power of 3 is not divisible by the root, which is 2. Does that make sense? So I need to break it down into something that is divisible. So the first number that's smaller than 3 that's divisible is going to be 2. So that becomes y squared times y. Agree? Now what about the x cubed? What happens to that? X squared times x. Okay, now everything is broke down inside the radical. What do I need to do? I need to cancel things out or take them out. So what is the square root of 9? Can I take the square root of 2? No. What about the square root of y squared? Can I take the square root of y? Can I take the square root of x squared? What is it? Can I take the square root of x? No. Why can I not take the square root of y and x? Because the power that's on each one of them is 1, and that's smaller than the root, which is 2. Do we understand that? So I leave that alone. And how's all the black on top attached? And how is the 14 attached to the radical? So what am I going to do with the 14 and all the black numbers and variables on top? Multiply them. So what's 14 times 3? 42 xy. See how I put them in alpha order? Times the square root of 2xy on the inside. Am I done? Why? I need to check to see if I need absolute value bars. So the first thing I check is right here. Is that even or odd? It is even, which means it's a possibility, right? I have an even root. So I may have a absolute value bars. Okay, then I'm going to check on the powers that are on the outside. So what's going on with the powers on the outside? They're odd, so therefore, could those possibly be negative? So what do I need to do to make sure that they are positive? Times the square root of 2xy. Do we all understand that, yes or no? Excellent. Now, we move to the last concept on your worksheet. The last concept on your worksheet talks about rationalizing the denominator. Now, do you remember whenever we did imaginary numbers, I said you could not have a imaginary number in the denominator. Do you remember that? And what we did is we rationalized that denominator by multiplying by its conjugate. Yes? Remember that word, conjugate? Okay? Well, the same thing is going to apply here. We can never have a radical in the denominator. And many of you are saying to Mrs. Yoder, I don't have a radical in the denominator. But you technically do. If I divorce those two, the numerator and the denominator, what does that give me? The square root of 9x over the square root of 2. Do we see that? Yes or no? Yes. So what is the square root of 9? That comes out as 3. Can I do the square root of x? No, that stays inside there. And then I have the square root of 2 on the bottom. Does everybody see that I have a radical on the bottom now? Now what we're going to do is multiply by a value of 1 over 1. But that 1 over 1 is going to be what we need to create that denominator to be a whole number. So since I'm taking the square root, how many 2's do I have to have inside that radical before 1 on the outside? 2. I need to have 2. What if I have the third root or the cube root? How many of them would I have to have? 3. What if it was the fifth root? I'd have to have 5. Do we understand that? So in this case, I am going to recopy this numerator and I'm going to recopy the denominator. What I'm going to multiply this by is I currently have 1 2 in the denominator. I need there to be another 2 there. So I'm going to multiply by the square root of 2 over the square root of 2. Do we see that? If I marry those at the top, that gives me 3 square root of 2x over the square root of 4. And what is the square root of 4, folks? It is 2. So that gives me 3 square root of 2x all over 2. That is rationalized. Does that make sense? That is rationalized. Now I'm going to do one more problem. This is the last one. This is problem 27 on science homework. Now, the first thing we're going to do is we're going to separate this fraction, correct? So we're going to make this the cube root of 3a over the cube root of 4b squared c. Now, how many 4's do I currently have in the denominator? 1. How many do I need to have inside there to pull 1 4 on the outside of the radical? I need to have a total of 3 because it's the cube root. So how many more 4's do I need? I have 1 here. How many more do I need? I need 2 more. How many b's do I have down there currently? 2. How many more do I need? I have a root of 3, so I need 1 more. I have how many c's in the green denominator on the left? 1. How many more do I need to pull it on the outside? 2 more. So I'm going to multiply by the cube root of 4 squared b c squared. Now I'm going to marry the tops. What's 4 squared? So that's 3 times 16, a, b, c squared, all over. Now how many 4's do I have total? 3 of them. How many b's? 3 of them. And how many c's? 3 of them. Well, what's 16 times 3? 48. And what happens whenever I take the cube root of 4 cubed? That gives me a 4. How about the cube root of b cubed? B. And how about the cube root of c cubed? C. However, we're not done. And you know why we're not done? Because are there factors of 48 that are perfect cubes? Well, what's a perfect cube? 2 times 2 times 2 is 8. Does 8 go into 48? Yes. Well, that's going to give me 8 times 6 abc squared all over 4bc. And what is the cube root of 8? 2. So that's going to give me 2 times the cube root of 6abc squared all over 4bc. Well, what can I do with the outside numbers? I can reduce that to give me the cube root of 6abc squared all over 2bc. Now it's reduced and rationalized. And I am done. Do all of your homework tonight, and we will go over any questions you have tomorrow.